Imagine me and you, I do. I think about you day and night. It's only right to think about the girl you love and hold her tight.
Welcome to Crazy Carrot Studios. My name is James, and today we will be going over creating a third-person controller with a new input system and Cinemachine. Alright, back in our project here, we're going to do a little bit of maintenance before we get started with this. First, I'm going to go ahead and make sure my canvas is deselected, and inside my script manager, I'm going to deselect the button script, as we do not need it. Now, because we are not going to be using the canvas, there is some things you can do if you don't want to lose what you've created. You can kind of, let's say, go back into our prefab folder and just call this one UI, just so we can separate the prefabs. And I'm going to drag my canvas straight into there. And now my canvas itself is a prefab, and I can delete this and bring it right back in anytime I feel like it. It did inherit that, but it still works, as you can see. So that being done, I'm going to delete mine, and I'm going to remove my button script completely. Because in this episode, we are going to try to make sure we use a game controller using the new input system and Cinemachine. Now, when doing so, there are a few things we need to do. In the top, click on the tab Window. Next, we want to drop down to Package Manager. In the following pop-up, click on the tab and drag it to Unity Registry. By typing Input in the top right, you can find the input system inside the packages. Once you are there, click the Install button in the bottom right. Once you select Input, you will be given a pop-up that asks you to restart. You want to do this in order for it to download the back-end packages for the input system. Once your project restarts, we want to go back in and do the exact same thing, but this time to Cinemachine. These should be the only two packages you need to create the project we are working on. Now that we have that done, we have one more thing we need to check on before we can continue. Go to Edit, go to your project settings, scroll down on the Player section to the bottom, and we're going to look inside the Other settings. It'll look like this. And down towards the middle to the bottom, we will see Active Input Handling. It's under the Configurations part. If you're going to use the old input system at all, you want to put both. We are primarily going to be doing the new input system on this one. I'm going to leave mine at both just so I don't have to restart mine, but either one, it'll work, but input system new is what you want. Okay, I'm going to do a few adjustments to set up our scene a little bit so that when we start enacting, we have something that has a backdrop so we can see that moves. First, I'm going to change my ground to a texture. Now, you notice when I drag in a texture, it stretches it. And that is because on our ground, we are at a 10 by 10. So on my ground material, I need to go down to Tile and also to 10 by 10. That'll make sure the tile will match what the ground is, and it's not stretching over the entire one. Now all I'm doing is using a texture material that I've created. Now you can use this from anything from Unity's asset store that has a lot of free ones as well as paid ones, or any image off of Google will work. Now, not everything is seamless, and so you want to usually try to find a seamless texture so you don't see the line so much when you're looking at it in a game view. Next, I'm going to create a game object. Let's go to a cube, and we're just going to make this, call it a wall. And then let's go to my scene view. Let's go ahead and raise that up so we can see it. I am going to stretch it. We'll make it about 10 in that way, and 5 high. And this is just so we have a little backdrop, and when we move we can see something behind it that shows that you're moving. And I'm going to duplicate that and create another one. Okay, let's go ahead and bring our ghost in. And I got our prefab, and I'm going to go ahead and use the red one again. Let's take a look. That looks about right. Alright, let's start by going back into our scripts folder right here, and we're going to create a new asset, and this one's going to be called Input Controller. You have to scroll down here to the bottom, and you'll see Input Actions. We're going to create that, and we're going to call this the Player Controller. Now, when you double click on this to open it, you're going to get a pop-up screen that looks similar to this. Basically, what the action map is the grouping of the different actions. So you can have several different action maps. Let's say one for the player, which is what we're going to create. And let's say if I wanted another one, I could create one for the menu or a UI or anything like that. I guess I didn't hit play. Let me retitle it to player. Okay, now that we have our player action map, in the actions we're going to create a movement action. And this movement action is going to be a pass-through and a vector 2. The reason why it's a vector 2 and not a vector 3 like we did in the C# tutorials before is because you're not having it go up and down. You're having it move side to side and forward and backward. So it's only two vectors that you're working with. We're going to delete this one here. And we're going to add an up, down, left, right composite. This one is going to be representing our keyboard, or WASD. In the up, we can just come in here, and if you type in listen and type your W, you'll see that the W keyboard comes up. That's all that is. Down, same thing. Come over here to listen. We're going to S. Left, obviously, will be listen for the A. And right, we're going to listen for the D. And it's that simple to create that part of it. Now, let's say we want to add a gamepad instead of the keyboard. Well, again, it's just that simple. We're just going to add a binding. Now, the difference with this binding versus this one is on the gamepad, we wanted to make it a gamepad, and we're going to use it the left stick. Now, this would be perfect if all we wanted to do was move. But in most cases, you want to be able to use your mouse to look around and see what's going on. So by doing another action, we can call this one rotation, or rotate, or look, or whatever you want to call it. It helps if I can spell. And then we're going to pass in the mouse. Now, luckily for this, if you go into and go back in here, it comes with another mouse. And what we want to do is find the delta for that mouse. So we need to make sure that this rotate is not a button, but a pass-through vector 2 as well. And that's why I wasn't able to see that. Now, if we go to the mouse now, you'll see the delta. And there you go. Now, adding the gamepad to the rotate is basically the same thing as we did before. We're going to add a binding, make sure it's under the rotate action. And then for the path, we're going to drop down and make sure we go to gamepad. And this time we're going to use right stick. And it's as simple as that. Now we have a move and a rotate. And let's go take it one step further. If we wanted to create a jump function, we can create another action called jump. And in this particular case, we want this to be a button. We do not want it to be anything else. So let's go ahead and set it up as, let's do the keyboard first. And we're going to do keyboard, and we're going to make it the space bar. And then for the gamepad, we're going to add the binding. And in this particular case, I'm going to use the gamepad and listen for the A button or south button. And just like that, we're set up for jump. Sprint is done the same way. I'm going to show that as well. Sprint. We're going to add the binding as a button. We're going to listen for the left shift. Now you notice it gives you both shift and left shift. Make sure you select the one that you want. And then for the gamepad, we're going to add the binding. And in this particular case, we probably want to use one of the upper triggers. So I'm going to do the left bumper or shoulder, whichever you want to call this one. And just like that, we have a sprint. Now once we're done with this, make sure you save your asset. If you don't, it'll still prompt you to see if you want to save it. We want to save it right here, and then we can exit out. Now, if you go to your script here, you'll notice here that it's got a generate C# class. If you click this and apply it, then it'll hard code all this, everything into the script. If you don't, it'll give you the flexibility of having users set up their own input. But for this particular one, now there are many different ways to do this. A lot of people will hit this generate C# class here and generate a script that hard codes the input bindings. The other way is using a player input on your actual character by going adding component and do player input. From here you can drag in your player controller straight into the player input, and that'll assign all your keys to it. Doing it this way allows you to set up your own binding for any game that you're creating instead of being set by the Unity script. Now, you notice that when we brought the player controller input action into here, it set our default map to our player, which is what we wanted. Now we just need to bring the camera down, and we're just going to drag it right into the camera slot so that it knows what it's referencing for. There are many different ways to write our move script. Unity provides a character controller that also comes with a code that you could also look through and use and learn from. But because we were trying to teach you a little bit of what everything does, we're not going to use it in this particular one. Now, that does not mean you shouldn't take a look at it. In fact, I will place a link in the description below so you can come and take a look how they did the same type of things. Now, for us, we're going to start off in here and we're going to create a C# script, and we're going to call this player controller. And we're going to open that up. And the first things we're going to do is we're going to remove these using statements because we don't need these two. We're going to add a using Unity engine .input system. Now, another thing I'm going to show you that is a neat little code here that you can do. Whenever you're trying to make sure that something is added, like we need the player input for this to work, you can do what's called a require component. Now this one says rigid body, but we're not going to do that. We're going to do player input. Just like that. And what this is going to allow us to do is, let's go back into our script and see what this looks like. If we were to go to our ghost here and remove this player input, and then take our player controller, add it to the, you'll notice it automatically added the player input back in. That is because we have the required component listed in here. So that right there, now if you did the same thing with any other script, it'll force it to come on, or any other component. Now that we have that set up, let's go ahead and assign that to a variable. So for us, we're going to call this a private player input, and we're going to call this one player input. We're going to save that. Now we're going to do another private, and just like before when we did a vector 3, this one is going to be a vector 2, and we're going to call this one move input. Now, just like I always do, whenever I'm doing a private, I make sure the underscore with followed by a lowercase is starting it all off. That way I know it is a private variable and not accessible to any other script. Now, the next one we do want accessible to us, but not to other scripts. So we're going to make this one a serialized field. And we're going to make it a private float, and call this one move speed. I can't type today. Excellent. All right, and from there we want to pass in a few things. This is going to be pretty much all the variables we're going to need right off the bat. In the awake function, though, which happens before start, we're going to go ahead and do we'll make sure we have that component, and we're going to get that component. This is assigning the component player input, which is right here. This player input section right here. Oh, we need to go ahead and reassign these. We took it off when I deleted it. And the camera. Okay, they're back to reassign. Basically, we want to reference this component. So by doing so, we come back into our script here. We're asking this variable player input to get the component player input. And that's going to attach it to this variable. Now, there's two new functions that we're going to introduce you to. The first of which is going to be called onEnable. The second will be onDisable. So on the onEnable, when you move your WASD or your triggers from your gamepads, as soon as you touch them, that's going to enable this action to happen. So we're going to go ahead and put player input.action. And of course, we're going to be getting that action from our player input that we had originally created. And we want to enable it with the capital E. That way we're referencing that function that Unity provides. Again, the player input.action is going to be located in our player input. Let's show you right here. Go to the Unity, our player actions. Right here in the action section, we're referencing the movement action in this particular case. So let's go back into our script. And we're going to do the exact same thing on the disable. So, let me get back in there. Started on a new function, not the same one. And we're going to do a private void on disable. And then we're going to basically copy or type the same thing out, player input.actions, but this time it's going to say disable. And that's going to reference the disable function that Unity provides. The next thing is we need to go over a couple different functions. One, we already know, the update, which runs once per frame. But there are also a fixed update and a late update. Now, fixed update can run once, 0, or several times per frame, depending on how many physics frames per second are set in the time settings, and how fast or slow the frame rate is. Fixed update should only be used when applying forces, torques, or other physical related functions, because you know it will be executed exactly in sync with the physics engine itself. Now, update can vary out of step with the physics engine, either faster or slower depending on how much of a load the graphics are putting on the rendering engine at any given time. If used for physics, it would give correspondingly variant physical effects. So when I create these next two functions, you'll understand a little bit of why we are creating that. Okay, in our update function, which runs once per frame, we're basically announcing that our variable move input, which we've got up here, which is a vector 2. We are basically saying that the player input.actions movement, which is what we titled our action here, and you got to make sure it's spelled the same way as what we have, and it's going to read a vector 2 value. So when I use my controller and I use the left stick, it's going to read the vector 2 value. Or if I'm using the WASD keys, it's going to read that vector 2 value and assign it to the move input. Now, inside of the fixed update, which, because this is a physics related and we want it to be in sync with what we're doing on the buttons, we want to make sure we assign these in there. So the move direction, which is a new variable we're creating, that is a vector 3, basically the same way we did the vector 3s in the previous episodes, that vector 3 is going to equal a new vector 3, and we're going to pass in the variable move input, but we're going to do it on the X and the Y value, but not the... And that's technically your Z. And we don't want it going up and down. We just want to move it left and right and forwards and backwards in this direction. Now, because it's a vector 2, it's assigning an X and a Y. But in the vector 3, it's still X, Y, and Z. It's just using the Y input from the vector 2. Now, just like in our previous one, we're doing a transform.translate. And we're going to go in that move direction. Now, the normalized, what that is doing is when you press, if you didn't have the normalized in there, if you press the up key, which is W, it would go, let's say, at a value of 1. And if we went on the A key going left, it would go also at a value of 1. But if we were to hit both of them at the same time, it would actually multiply it and do more like a value of 1.5. You would actually go faster going diagonal than you would going straight forward on a line. So what this does is normalize the vector so that when you're going diagonal with W and A, it's still going to pass it in that value of 1. And it's going to multiply it by the move speed that we set above. Now we can adjust our speed based on that. And then it's going to multiply it by time, not fixed delta time. And that way it's in sync with our actual movement on the keyboard or the gamepad. And that's going to be pretty much all we need to do to get our character to actually move. Now, this is not including the rotate or anything like that. We'll go through that in the next episodes. But this is so much easier than the old input system where we had to define for every different input, whether it be the keyboard or the controller. Now, through this one action, we can assign it through the movement, and it's going to do it through the vector 2 for both the keyboard and or the gamepad or anything else you assign to it. That's the convenience of the new input system. Now let's go ahead and make sure this is all saved and go back into our Unity project. Now, a couple things we probably want to make sure we do. Let's test this out here. One, we're going to go ahead and put our ghost back to the rotation of 0. And let's hit play. And one other thing, we got to move it C. Make sure you got it at least at a 1. And let's hit play. And let's see what this does. Forward and backward works perfect. Left and right also perfect. Now, if for some reason your keys are inverted for any reason, there are ways to get around it, and that's a convenience of this action as well, is for the movement action, if you wanted to set your inversion, you could do it right here. Or, if you wanted to normalize it here, you could do that as well. These are just some add-on features that the input system allows you to do. If you wanted to do on the button that you wanted to jump, but you want to on hold or tap, you could set that here. But we will go over a little bit more on the rotate, jump, and sprint in the next few episodes. But let's go ahead and take a look at this one more time. So now, forward and backwards. In fact, I'm going to move that speed up just a little bit so we can see it a little clearer. We're going to go 5. That's probably going to be pretty fast, but let's see. All right, left, right, forward, backwards. And that's going to do it for us this time. Next episode, we will try to get into the rotate, the speed, or sprint, and the jump, if we have time. And lastly, we'll get into Cinemachine, so we can have a fully functional 3D controller. And from all of us at Crazy Carrot Studios, we would like to say thank you. And don't forget to please like and subscribe. We will see you next time when we get back to Learning with Bob.
The skies